Hey, Luke and Kyle, and anybody else in the fifth period class that might be watching this. 6-3, test for parallelogram. We're still stuck on parallelograms. We haven't moved on to another shape yet. The next shapes that we have to do are rectangles and squares and that type of thing. But we're still on parallelograms because we got to study them further, all right? 6-3 is kind of the opposite of 6-2 in the fact that in section 6-2, they would give us a parallelogram. So give parallelogram, given parallelogram. They would say solve this. Okay? In section 6.2, they would say given it's a parallelogram, solve for x and y and z and b and whatever, right? Now they're saying, okay, looking at, I'm going to go down to example 1. Looking at like these things, if I label them that way, does this thing have to be a parallelogram? Does this thing have to be a parallelogram? Does this thing have to be a parallelogram? If I'm just labeling those things, do those guys have to be parallelograms according to what's given, right? Or could they be, slightly slanted the other direction, yeah, whatever. So we are trying to decide whether or not they are parallelograms, okay? That's not given to us. So these are conditions that have to take place in order for it to be a parallelogram. It has to fulfill one of these 4 requirements, okay? And some of them are pretty straightforward. Like the first one says, if the opposite sides are congruent, then it's a parallelogram. If the opposite sides are congruent, and that's the only thing that we know about this diagram, as long as the opposite sides are congruent, we know that that thing is a parallelogram, okay? They don't have to tell me anything about the angles, anything about it being parallel. If the opposite sides are congruent, that has to make a parallelogram. The way that it fits together, it will make a parallelogram. Okay? Second, if instead I know that all the opposite angles are congruent, if the only thing they tell me is that the opposite angles are congruent, then this has to be a parallelogram, right? Has to be, okay? And we can kind of track that back to like the alternate interior angles and the corresponding angles and all that good stuff, okay? If the opposite angles are congruent, then this has to be a parallelogram. They don't even have to tell me that this side's parallel to this one and this side's parallel to this one. If those angles match up, those guys have to be parallel. So that's, we can kind of cheat, okay? The third thing says that if the diagonals bisect each other, which means like this side right here is the same as this one, and this side's the same as this one. We don't even have to know any information about like the top and the bottom side or these two sides. We don't have to know that information. But as long as the diagonals are bisecting or splitting each other in half, then it's a parallelogram. So diagonals bisect each other. If that takes place and that's the only information that it gives me, that has to be a parallelogram, just the way that it's set up, okay? And then is this the last one? The last one. This one's a little bit far-fetched. Ready? A little bit far-fetched. This is the one that, like, it doesn't make a whole lot of sense. So this is the hard one. Chase, you better be watching this. Okay, this one's the hard one. Here's what it says. I know if the only information that it gives me is that this side is the same length as that one, and this side is also parallel to that one, that has to be a parallelogram. We know nothing about these two sides, but if the top and the bottom side, or just one set of sides, is both parallel and congruent, these other two have to follow. This has to be the case even though they're not labeled. That has to take place if the top and the bottom are labeled like that, okay? So if one set, just one set, is both parallel and congruent, right? They're parallel and they're the same length, then the other two sides have to be parallel and the same length as well, right? That has to be a parallelogram. This is the one that is kind of confusing, right? Like there's no way I can have this guy parallel and congruent to this one and have this not be a parallelogram. Like I could try to like slant this a certain way, right? And make this not parallel to this one, but then this would have to be longer, so that's not gonna work, right? So I could try to not make this a parallelogram, but it's not gonna work. If I have these requirements set, there's no way I can make this not be a parallelogram. Does that make sense? Okay, so we're trying to use these requirements to test, like, is it even a parallelogram or not, all right? One of those four things has to take place. All right, let's go down to this middle one. We'll go over here in a second because that one's kind of hard. But let's go to this one. Okay, if they give me that information, do I know for certain 100% that this is a parallelogram? It looks like it is, but is it for sure?
Yes.
Because of why?
It's parallel and same size.
Well, we don't know it's parallel though. We just know that these are the same length, right? Okay, but theorem 610 says, right up here, if the opposite sides are all congruent, if the opposite sides are all congruent, that's theorem 6.9. If the opposite sides are all congruent, then we know that that has to be a parallelogram. It doesn't tell me that they're parallel, right? They look parallel, but it doesn't tell me that. But if the opposite sides are the same length, then it has to be a parallelogram. All right, let's hop back over here. Okay, the only thing that I know is that this is 14 inches and this is 14 inches. So I have that side is the same length. I have this going on right here, right? And then I have the 100 and I have the 80.
610.
610 was the, which one?
Opposite angles are congruent.
Okay, but we don't necessarily know that the opposite ones are congruent. Like, I don't know that this is 100, right? They don't label that. I'm hoping it's 100. What?
Is it 690?
No, because I only have one set.
Oh,
Which one of those theorems has one set?
612.
612. Okay, so here's what 612 says. It says that they have to be both parallel and congruent. So I have to now show, I know that they're congruent, but does this guy have to be parallel to that guy, given the information that I have there, right? Looking at the 100 and the 80, if this guy here and this guy here are lines that continue on, right? Think of this as a transversal, right? Okay? If this guy is 100 and this guy is 80, then like, let's pretend that we like are looking at like this angle over here. What will that top angle be? 80. Okay, now this 80 and this 80 are alternate interior angles and they're the same measure. So does that mean that top and bottom are parallel? Yeah, if the alternate interior ones are the same, right? If this guy is the same as this guy, then those have to be parallel to each other. They can't be slanted a different way because they're the same measure, right? So now we have shown, given those two angles, that that top and that bottom has to be parallel, right? So is this truly a parallelogram?
Yeah.
Yes, because of
612.
theorem 612, right? So we had to grab a bit more information to prove that they're parallel, the top and the bottom. But because one set is parallel and congruent, we know that that is a parallelogram. Okay, let's go over here.
610.
You think?
Yes.
Okay, determine whether each quadrilateral is a parallelogram. It could be the case that these are not, right? Might be the case that these are not. Okay, so I gotta think. All right. Let's think here. All right, if they give me that those are 85s and this guy is parallel to this one, right? Let's try to show that this guy has to be parallel to this one. Maybe. Okay, nope, let's go back. 85. All right, so if that guy's 85 and this is a transversal, right? We don't know that those are parallel though. We know that they're congruent. We know that the same measure.
Opposite angles.
Yeah, but we don't know these opposite angles. We don't know that those are the same. We have to have all four.
You can't just have two?
Nope, you can't just have two.
But
Because this guy
don't they
could
have
be,
to be.
nope. If it's a parallelogram, they add up to be, whatever,
Oh.
right? So we have 85 and 85. If we add this together, that's 170. So this guy could be,
You know they're the same length. The top
this
and-
guy could be 40 and this guy could be 50.
But they're the same length.
What?
The top and bottom.
This one and this one are the same length,
Uh-huh.
but we don't necessarily know that this one is the same length as this one, right? So those could be different lengths. Like if this is 50, then this guy could be, 6 inches and this guy could be 4 inches, right? And then that wouldn't be a parallelogram, right? That could totally be a case. I don't think this is. None of these four requirements up here are met, right? We don't have any two angles and we don't have any two sides, right?
We have two sides.
Well, like two sets of sides, though, I mean. So I don't think this is. We could make this so it's not a parallelogram, given the information. So I don't think this one is. This does not fulfill any requirements.
Right.
it could so happen be the case that that's 40 and that's 50 and this is 4 inches and that's 6 inches, right? That still fulfills the requirement, right? But if that's the case, then it's not a parallelogram, right? Like none of these rules up here, we can't check off any of these boxes, right? So I don't think that's going to work. All right, so that one's going to be a no. Even though it looks like a parallelogram, don't go off what it looks like, go off what it's given. If what's given, does that give you enough information to say that it's parallel? For sure, 100%, right? Okay, my husband has to do kind of this same thing. It's a little bit far-fetched, but he has to do the same thing. I know we've talked about this before when he's building walls, right? So what they do is, like when they're building a wall, they build it on the ground, right? And this is how they build it, and then they put the studs here, which is every 16 inches. I don't know why it's 16 inches, but anyway, 16 inches they build them far apart. And that wall could ever so slightly be tilted this direction. I mean, that's a little bit extreme, but I'm trying to over-exaggerate it. If that wall is tilted ever so slightly this direction, those walls are not going to come together. So what he has to do is he has to run some tests to see whether it's a parallelogram or not, right? Or whether it's a rectangle or not, right? He has to like do some measurements to make sure that it's perfectly square like this, right? Does that make sense? Okay. So my husband, in a sense, is kind of running these tests to say like, okay, if I measure this distance or if I measure this angle, does that make it perfectly in line with each other, right? This is kind of like the tests that you're running, okay? So let's go here to the next question. Example 2. All right, this is a tackle box. Do you guys know what a tackle box is? You put your like fish hooks and, you know, like your bait and stuff in, whatever, okay? The diagram shows a side view of the tackle box. And the way that this tackle box works is it runs off of parallelograms. They're like hinges, right? And like it folds down, so like this folds down on top of that one and it folds inside of it. But these individual hinges right here are parallelograms. Like some engineer somewhere said, hey, if I set it up this way, it's gonna fold inside. And how like neat of a use of space there. Like they are making it so handy that like I can conserve space when it's folded down, but then when it's folded up, I can see everything. Like somebody came up with that and that was really brilliant, okay? So in this diagram, it says that PQ, which is this top guy here, is the same as RS, which is that, okay? And then it says PR, which is this guy, is also the same as QS, okay? Explain why the upper and middle trays remain parallel no matter what the height the trays are lowered to, okay? So if I have that this is matching this one and this and then the two sides are matching, does that in fact make this a parallelogram? If the opposite sides are congruent, does that make it a parallelogram? Parallelogram question mark. Is that enough information?
Yeah.
Why?
Because all sides are parallel.
Okay, all sides are congruent, not parallel, same length. They're the same length. And that's what Theorem 6.9 tells me, right? Theorem 6.9 says that if the opposite ones are the same, then they're parallel, okay? So if they're parallel, if that's a parallelogram, does this top tray gonna be parallel to that bottom tray?
Yeah.
Yeah, because this top side of this triangle, of this parallelogram has to be parallel to the bottom side. So it doesn't matter if this like is lowered a little ways, right? The fact that this makes a parallelogram is always gonna make this tray parallel to this one. If it did not, do you know what happens to the stuff inside of our tackle box? Yeah, if this one is slanted a little ways when we go to put it in there, the trays, for one thing, are not going to fit, but also everything in this tray is going to fall out of here, right? They have to stay parallel with the ground, and they do that by making a parallelogram out of this diagram right here, right? If this is a parallelogram, then we've got it set, okay? So, explain why the upper and middle trays remain parallel. Because the hinges make a parallelogram. Hinges make a parallelogram, okay? And so the top and the bottom trays are going to be parallel no matter what to each other. Happy with that?
Yep.
Make sense? Okay.
Can we do one more and then do homework?
No.
What?
I don't know. What's the next one? We got 2 more left. 2 more. All right, example 3. If FK, let's label some stuff on here. FK is from here to here. It's part of the diagonal. That is 3x minus 1. Okay, that's that length. KG is this guy right here, and that is 4y plus 3. This is kind of like close quarters, trying to like label this stuff in here. JK is this one right here, and that is 6y minus 2. And KH is this guy, that is 2x plus 3. Find x and y so that this is a parallelogram, okay? So they're giving each individual piece of the diagonal, like where they're split at, okay? And if this is a parallelogram, what do we know? Has to be true.
All the same length.
They're not all the same length.
They're the same angle.
No, they're not all the same.
FK equals KH.
Right. Okay, so Chase, take a look at this. This guy is longer than this guy, correct? Right, because they're opposite corners, they're going to be longer. But what I do know is that this little piece is the same as this little piece, right? Okay? Those two are the same as each other. And this little piece is the same as this little piece, right? The 4 pieces are not congruent to each other, but they're congruent to their opposite ones, right? So we can set the opposite ones equal, all right? Let's start with the x's. Should we start with the x's? Doesn't matter. 3x minus 1 will be equal to 2x plus 3. Do we see why that works? Yeah. Okay, beautiful. Okay, 3x minus 1 equals 2x plus 3. All right, so then we're going to subtract the 2x, and I'm going to add the 1 at the same time, plus 1. So x is equal to 4. Yeah, maybe? Okay, now if I do the other ones, 6y minus 2 and 4y plus 3. 6y minus 2 equals 4y plus 3. And I do some math. Minus 4y, minus 4y. And I'm going to add the 2 also, plus 2. And I have 2y equals whatever that is, 5. Okay, what's y going to be? What's 5 divided by 2? 2.5 or 2.5. Yep. There we go. X and y. The opposite ones have to be equal to each other. All right, last thing. Ready? They're going to give us points here. We're going to graph these points, and we're going to figure out using some stuff whether this is a parallelogram or not. And I have crappy drawings, so we're not going to go off of my drawing, but we're still going to draw it just to see where these are located. 2, 3 is K. So we're going to go K here. 8, 4. Sorry, we're off the chart. 8, 4. That is L. Let me get rid of some stuff here. M is 7, negative 2. And N is 1, negative 3.
Nope.
You don't think so? Well. You think it is? Maybe? I don't know. We'll see. Okay, we're going to do this 2 different ways. It's asking me over here to prove that this is a parallelogram or determine whether it's a parallelogram, yes or no, using the slope formula. Okay, we're going to also do this using the distance formula because on your homework assignment, they will ask you for distance formula instead. Okay, so we're going to do this 2 different ways. On your homework, you only have to do which one it's asking. So slope formula, distance formula. Ready? Okay. All right. As far as slopes go, okay, if this is a parallelogram, this guy's slope should be the same as this guy's slope, correct? Okay, so let's check to see if that's true. So going by the slopes, we're going to look at the slope, which is called M, right? Don't we use M for slope? The slope from K to N, okay, should be the same as the slope from what? K to N should be the same as the slope from L to M. Okay. And slope is rise over run. Right? So let's go from K to N. K to N, from N to K. How much is it rising and how much is it running?
Going over 1 up.
Up 6 over 1. So this guy would have a slope of 6 over 1 or just 6, right? Okay, his slope. Now let's go from L to M, or really from M to L. Is it also going up 6 over 1?
Over 1 up 6. Yep.
1, 2, 3, 4, 5, 6. I think so. So this guy has a slope of 6 also. 6 over 1 or just 6. Okay, now we've got to check the other 2 sides, which are what's the top one named? KL. And then we want to check also NM. We're going to check those guys' slopes. Okay, so KL from K to L is going what?
Over 6 up 1.
Over 6 up 1. So what's that slope going to look like?
1 over 6.
1 over 6. Okay. There's that. And NM
1 over 6.
is up 1 over 6. Okay. So the fact that these two are the same means that they are parallel. And the fact that these two are the same means these two are parallel, right? So if the top and bottom are parallel and the two sides are parallel, is this a parallelogram? Yeah, yes, it has to be. Okay, we've done the slopes. We figured it out. The opposite ones are the same, so we're good. Okay, now we're going to do instead. Again, you'll only have to do one or the other on your homework assignment, but we're going to do the distances instead, right? We're going to do the distances instead. So we're going to do the distance from K to L. We're going to do the distance from L to M. We're going to do the distance from M to N. We're going to do the distance from N to K. I don't care how you label these, but there's that. Okay? We're going to do just the distances. Okay? All right. Do you remember the distance formula? It's the square root of all that junk, right? Square root of all the junk, square root of all the junk, square root of all the junk, right? Okay? And we cheat by using the distance formula because we just look at the coordinate points, right? You remember doing that? If we're going K to L, we're looking at this point versus this point. How many units are we going in the X direction? Over 6, right? From 2 to 8, that's 6. So we do 6 squared plus. How many units are we going in the Y direction? From 3 to 4 is 1, so 1 squared. 6 squared plus 1 squared is the square root of 37. Is that right? Yes? Okay. So we're just going to leave it as the square root of 37. You don't have to convert it. Okay. Now let's do another one. Let's do another side. Okay. We're going from this time L to M. So we're doing these two right here. How many units are you going in the X direction? 1. And then we're going how many in the Y? From 4 to negative 2. 6, right? So 1 squared, 6 squared, that is another square root of 37. Okay. M to N. Are my bottom two? How many units are we going in the X direction? 6. And how many units are we going in the Y direction? 1. That's another square root of 37. Holy cow. And then my two left sides are from N to K. How many units are we going in the X direction? 1. In the Y? 6. The square root of 37 again. What? So we have all 4 sides of the same length. Do we have to have all 4 sides being the same length? No, what do we have to have?
2 sides being the same.
The opposite ones being the same length, right? So like this one's the square root of 37, whoop. Then this one would have to also be the square root of 37, okay? This one's the square root of 37, so this one also has to be the square root of 37. So only these two have to match and only these two have to match. It just so happens that all 4 of them match. That's just icing on the cake, right? They are all the same length, okay? This is something called a rhombus. A rhombus is like a square parallelogram. We're going to learn that later on in the chapter. Okay, but it's like a square but tilted to the side. All 4 sides are the same length. That's a rhombus. So using the distance formula, again, not all 4 of them have to match. Just these two have to match and these two have to match. Okay, but yes, this is a parallelogram. We've proved it using the distance formula instead. So on your homework assignment, whatever they give you, they'll either give you slope formula or distance formula. Okay, and you do whichever one it tells you to do to determine whether they're a parallelogram or not. Right? Good? Makes sense? Okay. So go to your homework assignment. Did I give you that already? Yes. Okay. So we're going to do all of the top ones. And on 1 through 4, it says justify your answer. Tell me which theorem, right? Like theorem 6.9 or theorem 6.10 or theorem 6.11, 6.12. If you put no, then it's no, right? Okay. So you're telling me whether or not this is a parallelogram based on the information that is given to you. Okay. Yes, no. If it's a yes, tell me which theorem. Okay. On these guys, I'm just going to have you do number 5 here. That's a slope formula. Okay. And do all of the bottom ones, 9, 10, or 8, 9, 10, 11. Okay, so you can skip 6 and 7 because those are like a longer problem. So you've got a lot of room to write out number 5 for the slopes. Okay. On the back side, do all of the top ones again, 1 through 4, same way we did before. They don't have you do any distances. We're just going to do another slope one again. So number 5, but not number 6. Okay, 7, 8, 9, 10. Do those. And sure, go ahead and do number 11. So you can skip 6 on that side.
Oh, I was on the wrong side.
Oh. Okay. All right.
What about on the other side?
So skip 6 and 7 on skills practice and skip 6 on regular practice. Okay, there you go. All right. Any questions before I stop the video? Goodbye, people.